Hello, it's video notes 10B, solubility and saturation. So we're going to be able to read a solubility curve and then also talk about saturation levels of a substance. So two main questions to answer are, will a substance dissolve and how much of a substance can dissolve? So will it dissolve? So the rule for dissolving is like dissolves like. So in this picture, you see molecules of water and molecules of ethylene glycol, and they're similar, so they mix together. And by similar, I mean they're polar and they have similar structures, and so they can mix together. So they're like each other, and so they like to dissolve. In this picture, here's the one structure of the motor oil, and here's the structure of water. And they are not like each other because water has this little tiny angle structure, and these molecules are big, long, chunking carbon hydrogen molecules. So nonpolar molecules and polar molecules don't mix. So like dissolves like is the rule, and here you can see more of the words to describe it. Will something dissolve? Polar substances and ionic substances generally dissolve in water because water is polar. And so these things are similar or like each other with the same kind of polarity and charges. So they dissolve and mix together. Nonpolar substances dissolve in other nonpolar substances, but not in water because water is polar and not like the nonpolar substances. So nonpolar dissolves nonpolar, and polar dissolves polar. And then ionic things also dissolve in polar substances because polar and ionic both have charges and partial charges. Okay, how much will dissolve is the other question. And so that is a term that we can use to describe that is solubility. Okay, and so here's the definition of solubility. Please make sure you write this down and understand it. But the solubility of a substance is the maximum amount of solute that can dissolve in a given amount of solvent at a given temperature, and that's called its solubility. Okay, so you would have to say, all right, if I have 1 cup of water, how much salt can dissolve in that water to figure out its solubility? Now, it depends what temperature too, because if you have really hot water, then usually you can get more solid to dissolve. Okay, so what affects how much can dissolve? Temperature does. So warmer solutions hold more solid usually, so they're able to dissolve more solid. But then gases also dissolve, and if you make a solution hotter, a higher temperature, then less gas will dissolve. Okay, and then pressure affects solubility mostly for gases only. Okay, so solids don't really get affected by pressure, but gases do. Okay, so if you have water or even soda pop, right? And you want to get more carbon dioxide to dissolve in there, that's CO2. All right. If it's cold, then you get more gas in. And so that's why when you have a cold bottle of soda in the refrigerator, oh, I know we don't drink soda bottles, but how about cans of soda? Oh, look, it's a can of soda, right? Colder cans of soda have more gas pressure and more gas dissolves, okay? But then if you have a hot, warm bottle of soda, then there's a lot more fizz that comes out because the gas doesn't stay in it. Okay, so saturation levels. Solutions can be saturated, unsaturated, or supersaturated. So that's the saturation level. A saturated solution is full of solute, so it reached its solubility, it's maxed out. Okay, maxed out with solute. So that means you can't get any more to dissolve in there. All right. Unsaturated saturation level means it's unfull of solutes. Okay, so that means there's some solute in there, but there could still be more. Okay, supersaturated saturation level is a special case where the solvent is holding more solute than it should. Okay, so these are crazy pictures, right? But each picture represents a level of saturation, just for an analogy to see. Now, you know these aren't solutions, this is chicken. But this container represents what kind of solution? this represents what kind, and this represents what kind. Okay, so this is saturated, it is full. All right, this is unsaturated, means you could put more in. This is super saturated and it's just not right. It's holding more chicken than it should. Okay, so that's just an analogy, just to give you a visual. But really, we're talking about a solvent and solute. And if it's got the maximum dissolved, then it's saturated. If you could still put more solute in, it's unsaturated. And if it's holding more than it should, it's supersaturated. Okay, so we can graph this. We can figure out, all right, at 20 degrees, so this line right here, every single point on that line represents a saturated solution of potassium nitrate, KNO3. So at 20 degrees, you can get about 40 grams of solute, KNO3, to dissolve in 100 milliliters of water. Okay. So at 20 degrees, you can get about 40 grams to dissolve. Grams of KNO3. All right, some people would say 38, but what about at 60 degrees Celsius? So at 60 degrees Celsius, we can read over to here. You can get about, reading the graph, you can get about 110 grams of KNO3. So the solubility of potassium nitrate at 60 degrees is 110 grams of KNO3 for every 100 milliliters of water. What about at 85 degrees? Well, we'd go to 80, there's 90, here's about 85, we go up, we go over. So the solubility to make a saturated solution is about 190 grams of KNO3 for every 100 milliliters of water. Okay? All right, so, oh look, it's another solubility curve. This time it's for salt, that's sodium chloride, and this is sugar. That is sucrose, okay? So you can see that sucrose is way more soluble than table salt. So unsaturated is, if you're talking about a solution at a temperature and then when you graph it, it's below the solubility line, then it's unsaturated, okay? So in the last slide, and still in this slide, if you land on the line, then it's a saturated solution. So if I had 150 grams of sucrose dissolved in 100 milliliters of water at 20 degrees, would it be saturated or unsaturated? So here's 20 degrees, here's 100. It's right there at that purple dot. It would be unsaturated because you could still get almost 100 more, almost 50 more grams to dissolve. Okay, so you can still add more sugar until you get to here at 20 degrees, and then it would be saturated. So it's below the line, you still could add 50. If 250 grams of sugar is dumped into 100 milliliters of water at 40 degrees, what would happen? So here's 40 degrees, here's 200 grams of sugar. Whoops, no, that's 200. So we want 250 at 40 degrees. Okay, we're up there. Now, the truth is, at 40 degrees, you'd only be able to get about 240 grams to dissolve. So it would be saturated, and in this case, and the extra approximately 10 grams would sit on the bottom. Sit on the bottom of the container, undissolved. Of container, undissolved. So we can't go above the line at a temperature, all right? So this amount right here would not dissolve. That would be undissolved, okay? If a solution is at 20 degrees and it's 50 grams of sugar, how much is needed to saturate? So we're at 20 degrees and we're at 50 grams of sugar. All right, so we can get up to the line, so we can do 50 more, 100 more, 150 more. So we'd be able to add 150 grams more to get to saturation. All right, so those are some of the questions you can get about that. All right, so how do you make a saturated solution? All right, and we want to make a saturated solution of sodium chlorate at 40 degrees. So we find out 40 degrees, we say, all right, right here, right? All right, so at 40 degrees, if we want it to be saturated, we have to be able to get 140 grams to dissolve. So if we want to make a saturated solution, then we would add approximately 140 grams of NaClO3 to 100 grams of H2O at 40 degrees Celsius and stir. And every bit of that should dissolve because that's its saturation point. So the grams are on the y-axis and the temperature is on the x-axis. All right. What if we want to make an unsaturated solution of sodium chlorate at 40 degrees Celsius? All right, so we're at 40 degrees Celsius. We went up to here before when we found out 140 grams would saturate it, so anywhere below, anywhere. Okay, so you can add less than about 140 grams of NaClO3 to 100 grams of H2O. All right, has to be less than the saturation line in order to be unsaturated. Okay, this is where we get crazy. How do you make a supersaturated solution of sodium chlorate at 40 degrees? We cannot make it supersaturated at 40 degrees. All right, what we could do though is heat the solution up to a higher temperature. Okay, heat 100 grams H2O to a higher temp, like let's go with 100 degrees Celsius. All right, add NaClO3 to saturate at that temperature. Then here's the key. Then how do we make it supersaturated? Cool it down very slowly and hope the extra crystals stay dissolved. Extra crystals stay dissolved. If they do, when you get to 40 degrees. If they do, then it's supersaturated. So at 100 degrees, woohoo, we can get this much dissolved. But then as we cool it down to 40, all right, then this many crystals, if they stay dissolved, then it's supersaturated. But most likely as it cools down, they'll drop out. So it doesn't always work, but you can make a supersaturated solution. You just have to saturate at a higher temperature and then cool it down slowly and hope those other crystals stay dissolved. Okay, so if you heat up water and saturate it, it has a bunch of solute in it. If you cool it down slowly, you'd expect the extra to precipitate out or turn to solid when it can't hold that, when that solvent can't hold that solute. It usually does, but some solutes don't do that, and now cooled solution has too much solute, so it's supersaturated. Okay, it's a fragile system. It's not going to stay that way for long, and the extra precipitate can fall out. It's called crashing out. Okay, so making rock candy is a utilization of a supersaturated solution. Okay, so here's a saturated solution at room temperature. When you heat it up, you can get more to dissolve. If you go back to room temperature and it stays dissolved and doesn't fall out, then it's supersaturated. Okay, so here's an example of a solution that looks regular. It doesn't look saturated, supersaturated, or unsaturated. We can't tell. All right, but if you add one more crystal, one tiny crystal, so here's one tiny crystal going in. When that crystal goes in, and all of the crystals, if it was supersaturated, all the crystals glob onto it, and then the solid comes crashing out. crashing out. A bunch of precipitate comes crashing out, then it was supersaturated. After it's done crashing out, then all of the solution that's there is saturated and the extra solute just stays. Okay, another example. Unsaturated still dissolving at 25 degrees until we have 91 grams dissolved, 9 grams undissolved, and saturated. You heat it up and all 100 grams dissolved, then it's unsaturated, we could put more. Okay, if we cool it down slowly and we get back to 25 degrees and all 100 grams stay dissolved, then it's supersaturated. But if the precipitate forms, it becomes saturated again. All right, this is one way it could look when it starts to come crashing out. Those pretty crystals form. Okay, what kind of questions can you get about this? Well, we did some already, but we have some more. All right, so at what temperature would a solution have 80 grams of KNO3 dissolved? Okay, so 80 grams of KNO3, go over, and then the lowest temperature that can happen at, the lowest temperature that can happen at is about 42 degrees. About 42 degrees Celsius. And actually, any higher temperature than that, it should be able to dissolve 80 grams. Okay. What mass of KBr can saturate a solution at 70 degrees? So let's find 70 degrees here, 70 degrees, and this time it's KBr. So we're a little, so here's 90. We're at about 90 grams of KBr would make a saturated solution at 70 degrees Celsius. Okay, how to test for the type of solution? So how to test for a level of saturation? So a beaker with a solution in it, so here's 3, right? They're solutions. They all look the same, right? It is saturated solution if you add a crystal. All right, so we'll add a crystal. One crystal goes in. That crystal sits on the bottom, sinks to bottom, and doesn't dissolve. And does not dissolve. That means it was saturated already. Okay, in an unsaturated solution, one crystal, you put it in, and then guess what? It disappears. Okay, in an unsaturated solution, that crystal that you put in dissolves. Okay, so you know it was unsaturated because it took one. In a supersaturated solution, you put that one crystal in, and then all of a sudden, a bunch of precipitate forms. In a supersaturated solution, the crystal causes a large amount. One tiny crystal causes a large amount of precipitate to form. I'll put crash out. All right. So you can't tell by looking what kind of saturation level your solution has, but you could test by adding a crystal. And here are the results of adding a crystal to tell you whether it was saturated, unsaturated, or supersaturated. Okay, so to review, know your definition of solubility. Know that like dissolves like. Make sure you read the solubility curve. The line is saturated, below is unsaturated. Supersaturated is a special case that you have to work to make happen. And then make sure you can read the solubility curves and discover at home. So we'll do some practice, and then we'll give you some activities you can do at home to see if you understand solution chemistry. Okay, so here's the objective. Hopefully you can do those, and we're done.